share, listen to Aloore Radio on Facebook. Aloore Radio, the voice of Oyo State. Gẹ́gẹ́ bí ìwòye àwọn òmòye tó ní òye bó ti yẹ kí ìlànà ètò ẹ̀kọ́ tó gbangba sùn lọ́yẹ́ orí gan lóde òní yàtọ̀ fáwọn ẹlẹ́bọ̀wọ̀wọ̀ tó lùgbòrò pa lórílẹ̀‐èdè yìí lọ́wọ́lọ́wọ́ báyìí ẹ̀sìn tó ń síwájú ọ̀hún rèé ilé ìwé Monarch Model College Challenge nìbàdàn àwọn ọ̀jọ̀gbọ́n onímọ̀ nípa ọ̀rọ̀ ìlànà ètò ẹ̀kọ́ nílẹ̀ yìí àti lókè òkun ló kórajọ pọ̀ síbẹ̀ àwòsífìlà làwọn èlò ìkẹ́kọ̀ọ́ ìgbàlódé tó sọnù síbẹ̀ àyíká ilé ìwé ọ̀hún rẹwà púpọ̀ ẹ̀rọ CCTV kámẹ́rà ń bẹ ní yàrá ìkàwé pẹ̀lú akẹ́kọ̀ọ́ péréte ní kíláàsì kọ̀ọ̀kan àwọn èlò eré ìdárayá tó kójú owó àwòmọ́ lè lọ lóríṣiríṣi àwọn akọ́ṣẹ́mọṣẹ́ olùkọ́ tó kójú òṣùwọ̀n ní kọ́mọ lọ́dọ̀ wa yàrá ìkọ́ ìmọ̀ ìjìnlẹ̀ sáyẹ́ǹsì tó sọ wọ́n nílẹ̀ yìí gbà ọmọ kan kọ̀ǹpútà kan ní bẹ́ẹ̀ lọ́kọ̀ bẹ́ẹ̀ tí ń káwọn akẹ́kọ̀ọ́ wa láàárọ̀ lọ́sàn-án lójoojúmọ́ pẹ̀lú owó iléèwé tí ò gún pa rárá ayò nílé ìwé yìí jẹ́ fún gbogbo òbí àtàlágbàtọ́ ètò ìgbaniwọlé lọ lọ́wọ́ báyìí o sí ẹ̀ka ti JSS 1 to 3 àti ti SS 1 to 2 Monarch Model College wà ní plot 86 and 87 Polaniwa Street Police Post Challenge Ibadan 08169799661 website www.monarchmodelcollege.org Monarch Model College nìbàdàn ibùdó ìmọ̀ fáwọn afàṣẹwà lẹ́yìn ìwà ọ̀la.
Welcome to Monarch Model College, a community of kings and queens. We are located at plot 86 and 87 Polaniwa Street at the back of Equa Church, Challenge area, Ibadan. You are welcome to our teaching on air episode for this week.
Titled Moment of a Force. Before we start, we know about the definition of the moment of a force. Now we start with the concept of movement. What do you understand by the word concept? The word concept means the basic idea of something. Exactly. Now, what is an idea of a word, a moment? For instance, if you are hearing the word moment for the first time, what comes to your mind about moment? Are you with me? Now, the first thing on the projector is you see that whenever we open a door, take note, the force we put on the door and do exact a tonic effect about the word hinges. You all know a door, isn't it? Now when you open the door maybe at home, in school. Now when you open the door, exactly maybe your bedroom, you open the door and you close it. You know that the door open and it closes, exactly. There's something that held the door from opening and closing. It's called hinges, exactly. Now you know that the hinges is stable, it's not moving. And there are two hinges oftentimes for doors, one at the top, one at the bottom, exactly. Now you see that the door will rotate by closing and by what? By opening. But the hinges still remain the same, does not move. But what moves is the what? Is the door. Meaning that the door rotates about the what? About the hinges. How? By applying force to the door. Exactly. Now number two. When we ride a bicycle, and let me say this, how many of us have, maybe you have ride bicycle before, let me see. Okay? That means majority of the class. Okay, very good. Now, once you ride a bicycle, what do you observe? When you ride a bicycle, the push you exert on the pedal with the feet produces a tonic effect which causes the wheel to rotate. That means it takes the pedal of the bicycle to cause the wheel of the bicycle to do what? To rotate. Meaning that if you don't apply a force to the pedal of the bicycle, will the wheel rotate? No. It means the force exerted on the pedal is what causes the wheel of the bicycle to do what? To rotate. Are you with me? Now, also, number three, leveling a bottle cap or cork with an opener. Many of us will take soft drink. Obviously, you take something like, for instance, Coke, Fanta, Mirinda, and so on and so on and so forth. Now, if you want to open it, what do you use? Use opener. Exactly. Now, if you want to use the opener to open, what do you apply? Force. Very good. Now, you open it, you apply a force. Exactly. Now, when you apply the force to open it, it means that a force has been applied on the cork. Exactly. Without the force, no opening of the what? Of the cork or the cap of the bottle. Now, generally speaking, if you check these 3 points, something is common. And what is that? Force. Force is needed to open a door. Force is needed to ride a bicycle. Force is needed to open the cap of what? Of a bottle. Thank you. Now, also, apart from force again, there is also a distance. You know why? When you apply a force on the pedal of the bicycle, what happens to the bicycle? It moves forward. Exactly, meaning that it covers a particular distance. Likewise, if you apply a force to the door and you open, it does open exactly some distance. Likewise, the cap too. Exactly. Meaning that when we talk about the movement of a force, there are two parameters needed to be put into consideration. The first one being the word force, the second being the word distance. Thank you. Next slide. Now I want to define what is a what? A moment. The moment of a force about a point or axis, capital C, that same center, is the turning effect of the force about that point. Is equal to the product of the force and the perpendicular distance of the line of action from the point C. Meaning that moment, when talk about the moment of a force, the moment of a force about a point is the turning effect of that force about that particular point. Or moment of a force is the product of the force and the perpendicular distance. And okay, from there we now have to talk about the formula of moment. As soon as moment is equal to what? Force times what? Perpendicular distance of pivot to the line of action of the what? Of the force. Now, mathematically, M is equal to what? F times what? Times D. Now, since force is in Newton, capital what? M, and distance is in meter, the SI unit for moment is expressed as what? Newton meter. That is what? M meter. It is what? A vector quantity. Now, it means that small letter M to denote moment times capital F to denote what? Force times what? D. And this is called what? The formula for moment. Meaning force times what? Distance. Let's call this equation what? Equation 1. Very good. And what is the unit for moment? Newton meter. Very on. Why? Because force is in what? Newton, and distance is in what? Meter. And if you multiply Newton and meter, that will give us what? Newton meter. Very good. Now, and we said that moment is a what? A vector quantity. Can anyone help us out with what is a vector quantity? Okay, Josiah, what is the vector quantity? Vector quantity has both magnitude and direction. Thank you. Very good. Please clap for you. That means a vector quantity is a quantity that has what? Both magnitude and direction. Now, when we talk about the word magnitude, now the word magnitude means what? Value. Exactly, value. And we have what? Direction. Okay, now look at this diagram now. We have figure A and figure B below. A moment of a force about what? An axis or a what? A center C. Now if you check on the projector, it means you see that we have this center, this is center C and center what? C. Exactly. Now you have a force here, capital what? F, and you have small d, the distance, isn't it? Now here also you have what? F, and you also have what? D. Exactly. Now for this equation, for this figure 8, the formula for moment will be what? Force times what? Distance. Why? Because you need to apply a force to cover a distance from here to here. Exactly. Now in this case now, also we have force and what? Distance. But you observe that as regards to this, there was no angle. But this has what? Angle. And what do we have here? Angle theta. Now if I draw this diagram, let's say I want to show you another formula of moment apart from N is equal to what? Force times what? Distance. Now if you look at that second diagram, figure B, you observe that you have a shape like this. And you have something like this. And you have this. Then here is what? Theta. Here is what? And 90, God bless you. And here is what? D. Exactly. And here is the F, the forces. Are you with me? Now, how did we get our D to the side what? Theta. Are you with me? Now, you know that this is the right angle triangle. Exactly. This side facing the what? Angle 90 is called what? Hypotenuse. This side facing the given angle is called what? The opposite. And in trigonometry ratio, if you combine opposite with hypotenuse, what angle is that? So, very good. Sine. So, very good. Now, sine theta now will give us what? Opposite over what? Hypotenuse. Very good. Now, what is our opposite here? Now, let's call this place, for instance, let's assume that we don't know this place to be what? D sine theta. Let's call this place what? Y. Are you with me? But I want to derive from you how from the textbook they got what? D sine what? Theta. Do you understand? Now let's assume that this side is what? Y. Now sine theta is equal to what? Opposite over what? Hypotenuse. What are our opposite here? Very good. Y. What are our hypotenuse? D. Thank you. Now from here we have sine theta is equal to what? Y over what? D. And let's make what? Y the subject of the formula. Y is equal to what? D times what? Sine theta. Therefore, Y is equal to what? D sine what? Sine theta. That's why here we have what? D sine what? Sine theta. Therefore, moment, right, because what? Capital F, everything, times D sine what? Sine theta. Equation what? 2. Equation 2. Now, what is now the difference between equation 1 and equation 2? Equation 1 is, you can use equation 1 to solve a question if, very good, without angle. If angle is not being given. Equation 2 is used to solve what? To solve a question whereby an angle is needed or an angle is given. Very good. Thank you for that. And let's proceed. Now look at that now. You have moment is equal to what? Force times what? Distance. In figure what? Figure A. 5 figure B is what? Force times D sine theta. Exactly. Now because figure B has what? An angle. Thank you. And let's now do some calculation under moment based on what I've explained. It's not difficult. It's very simple once you understand the concept behind moment. Exactly. Now example 1. Calculate the moment of a force 50 Newton about the what? Distance 2 meter. Now the first thing is this: as a physics student, if you want to solve any question in physics, you must always learn to state your what? Parameter. It's the parameter that will tell you how to apply your what? Formula. Exactly. The first thing is to state your what? Your parameters. Okay, what are our force from that equation? 50 Newton. Thank you, 50 Newton. Our distance? 2 meter. Now what is the formula for moment? Force times distance. Very good. Therefore, what are our force? 50 Newton. What are our distance? 2. Very good. Therefore, M is equal to 50 times 2? 100. So can anyone? Very good. Newton meter. That is the what? That is the answer for that. Do you understand? Yes. Any questions? Okay, let's proceed to example 2. Example 2. If the moment of a force is what? 200 Newton. Can I go this side? Yes. Okay. Force is what? 200. Don't forget, always state your what? Your force is equal to what? 200. I mean, the moment rather. Sorry. Because the question says, if the moment of a what? Of a force is what? Now, moment. Moment is equal to 200 Newton meter. Very good. Now, calculate it what? Force. Force. Okay, and what? Distance? 50. Excuse me. 50 what? Centimeter. Okay, now we want to get our moment. Moment is equal to what? Force times distance. Very good. But you observe that your distance is in what? You convert to what? Meter. You know why it's a meter? Because the SI unit of distance is what? Very good. Now, to convert 50 centimeter to meter, what will you do? Very good. Divide by 100. That is 50 over what? 100. Please cancel, please. 5 here, 5 here, 2. That is 1 over what? 2. Please got what? 0. God bless you. Meter. Therefore, we are looking for what? Force. This is it. Now, force is equal to what? Moment divided by what? What are moment? God bless you. What are distance? 0.5. Exactly. Now, let's convert this to fraction to make it easier for us. You have 200 divided by 1 over what? 2 over 1. That is what? 200 over 1 times what? 2 over 1. Exactly. Then, thank you. Therefore, our force is what? 400 Newton. Are you with me?
Yes.
Okay, thank you for that. Now we have done example 1 and example what? Example 2. Now let's see example 3 now. The case is quite different from what? Example 1 and example 2. Because in example 3 we are given what? A diagram. Exactly. Now if the moment of the force F about an axis through O in the figure below. Now please carefully look at the what? The figure above. Now you will see that in that diagram you have F1, you have F, and you have what? Fs, and what? Theta with the distance letter what? A. Very good. Now we are now asked to solve to find the moment of this force about this point. Meaning that from this diagram there are two forces acting on this diagram specifically. Exactly. We have the force Fy acting what? Vertically. And we have force what? Fs acting what? Horizontally. Are you with me? And we know that moment of a force, exactly, is a product of what? Force times what? Distance. Or the moment of a force about a point is the turning effect about that particular what? Point. Do you understand? But how do we now solve this now? To solve this, we will resolve this force into two components. We are going to do what? Resolve the force into how many components? Two components. Very good. Which are what? Which are what? Vertical component and horizontal. Very good. Now, resolving. Resolve the force into component. Into component. And let's have a vertical what? Component. Now for the vertical component, now let me draw this diagram for easy understanding. You have this. You have this. You have this. Meaning that I just extracted this. I need the class. Okay. Yes, what? Theta. Yeah, we what? 90 degree. Yes, our F. Yes, what? Fy. Yes, what? Fs. Very good. I love that. Now, with this now, resulting to vertical component, that means you are dealing with what? Fy, and what? And theta. Excluding what? Fs. Why? Because Fs is acting what? Horizontally. Very good. Now, combining opposite with hypotenuse under trigonometry ratio to give us what? So, which is what? Sine. Very good. Now, sine theta is equal to what? Opposite. Very good. What are opposites here? Fy. Thank you for that. Fy. And our hypotenuse? Very good. Now, that means sine theta is equal to Fy over what? F. When I make my Fy the subject, that will give me what?
Fy equals to F sin theta.
Sin theta, God bless you. Exactly. That's what the vertical component. Now, let's go back to horizontal what? Component. Horizontal component. Now, this Fs, according to what sign is this? The adjacent. Very good, my dear. This is what?
The hypotenuse.
This is what?
The theta.
The theta. Very good. Now if I combine the adjacent and the hypotenuse under trigonometry, that will give us what? Very good. Now, car, you give us what? Cos what? Theta. This is cos what? Adjacent. Very good. Now, what about adjacent?
Fx.
Very good. Then, what about very good? F. Therefore, cos theta is equal to what? Thank you for that. Now, if I make my word Fn the subject,
Fx is equal to F cos theta.
thank you. Now, that means you have gotten our word moment. Because the question says what? Find the moment of the force M in back what and axis to center what? O in the figure below. That means I've gotten my force for the vertical and what horizontal component. Exactly now. And you know that recall. The word recall means what? Remember. Recall that moment is equal to what? Force times what? God bless you. And also when I define moment for you, I said moment of a force about a turning effect. Exactly. Is the force that is the product of the force times the what? Perpendicular distance. Actually, from that definition, the distance we are talking about means the distance only takes place in the direction of the force. And in mathematics, when you hear the word perpendicular, it means that a line is going like this, and that is what is coming. Are you with me now? Because what a perpendicular is what angle 90. Now, if you want to get the moment now for vertical component, moment for vertical component. Vertical component. That will give us M is equal to force. Now in this case now, if you check this force here, this Fy to this horizontal is acting what? Perpendicularly. You know why? It forms angle like this. 90 degrees. Exactly. Therefore, this place now, which is what F, we change to what? Fy times what? Times D. Exactly. And from what we just proved now, Fy is equal to what? F sin. And it's F sin theta times what? D. Very good. Now, therefore, we now have what? F sin what? Theta what? D. Exactly. Or better still, you can say FD sin what? Sin theta. Are you with me? Now, for the horizontal now, class, now I want to pay maximum attention. For the horizontal, you will see that the force F is acting what? Downward. Exactly. Against what? The horizontal distance A. But now listen, sorry for this. The distance is what? A. And it's here should be what? A and not what? D. Why? Because the diagram gave us what? A. Very good. Therefore, here will be what? F. A. Exactly. Now, for the horizontal component now, moment for horizontal component. Now, moment for horizontal component. Moment for horizontal component. Now, that will give us what? Now, take note. I told you that this force Fy is acting what? Downward. Against what? The distance. Exactly. When it now comes to Fx does not have perpendicular distance. You know why? Fn is only acting towards what? Horizontal. Are you with me? Yes. Now, since it's not acting towards horizontal, I get me. Because under vertical, we have what? Fa sin theta. Exactly. But because this Fx exactly does not have a what? A perpendicular distance. Therefore, the distance will become what? 0. Because this Fs does not have what? Perpendicular distance. Are you with me? Are you with me? Is that coming again? Fy has perpendicular distance. You know why? This is the horizontal and this is the vertical. But if you look at Fs, it's just what? Acting what? Horizontally. That means the force is not acting downward. How is it acting? Horizontally. Therefore, the distance becomes what? 0. Now, we now have that moment is equal to F times what? A. Now, moment is equal to what? F what now? Fx times what? A. But because it does not have perpendicular distance, this A becomes what? 0. Very good. And we know that our Fs gave us what the last time? F cos what? Theta times what? 0. Therefore, F cos theta times 0 will give us what? 0. God bless you. 0. It means the moment for the what? For the horizontal is what? 0. For the vertical is what? F is sin theta. What's our formula? Newton meter. Do you understand?
Yes.
Do you understand?
Yes.
Okay. I've made earlier on. I want to show us the pictorial diagram of moments. Exactly. And you will see on this chart, we call this instructional material. And you will see on the chart, we have moment and what? And couple. Now, moment of the force. The tendency of the force to rotate the body to which it is applied is called the what? Moment of the force. Now, look at this now. Look at this door. Open. Exactly. The hinges are here and here. Exactly. The hinges is what holds the what? The door to the wall. That the hinges other to the door to follow. Exactly. That's why you said the hinges will never move. It is fixed. Exactly. But it's the door that what that will rotating by closing and what and opening. You understand? Now see, opening a what? Now look at this also. Riding a what? Bicycle. Look at this. Look at this. Let's say this is a girl now riding a bicycle. Exactly. Now you see that she applied a what? A force on the pedal. Exactly. And the force is pointing out. It's pointing out downward. See this arrow? Pointing what? Downward. Are you getting that? And we also have what we call leveling a what? Bottle cap. You see an opener used to open a what? A bottle. Do you understand that? Now take note. Moment of the force about a point or axis is what? Force capital F times what? Perpendicular distance from the what? Axis is the line of action for the force F. Now when you talk about distance, distance can take any letter. It can be D, it can be A, it can be what? L. Now why do we always call it perpendicular distance? Is because look at this guy. When he applied the force, the pedal turned towards what? Downward. Meaning it's pointing down. Exactly, vertically. Can you understand? Now, it's not possible for you to pedal the what's it called, the bicycle, and the pedal will not go to your hand. It must point what? Downward. Once this pedal points downward, what happens to the wheel? It rotates and moving forward. And for you to keep your balance, what we have to do? You have to keep rotating the what? The pedal. Do you understand? Yes, sir. Very good. Let's proceed. Okay, now look at this. Before we start this, let me explain this to you. Now you see from that diagram, we have weights. Now you see something, you see this. We call it the diagram a what? A beam. But this beam can be likened to what? A meter rule. What is a meter rule? A meter rule is used to measure what? Length in the laboratory. Now this one you are seeing standing before me is called a pivot or a knife edge. Exactly. Or a fulcrum. Exactly. It's used to hold the what? The meter rule. Now, look at this knife edge and the meter rule. I will place this. Now look at this now. See how it's stable. Though it's tilting left and right. Now at this point that is stable, it's called what? Equilibrium. What do I call it? Equilibrium. The word equilibrium means the object is constant or the object is what? Stable. Exactly. Now that means the weight on this side and the weight on this side is what? Is balanced. God bless you. It's equal. Very good. Now this equilibrium you are seeing now is a case study of when you are young, when you are in primary school. That you write them called seesaw. Very good. Seesaw. Very good. Now, you know that in that seesaw it moves what? Up and down. You know that if I place this marker here now, this line will do what? We tilt to this place. Why? Because of the what? Of the weight. Do you understand? Now, you now have the typical question as regards to this. Now, weight of 20 Newton and what? 50 Newton are hung on a light beam as shown in the figure what? Below. Very good. Find the moment of the forces about what? O. Now look at that diagram. We have this is the what? Knife edge or the pivot or the fulcrum. Exactly. On this side, a weight is being hung. What is the weight? 20 Newton. On this side, another weight 60 Newton. Now take note. Observe something that I want to explain now. You see that here we have what? 20, here we have what? 60. Now between this and this, you have asked the higher weight. 60. That means this meter rope will tilt towards what side?
The right side.
Very good. Towards the right side or towards the 60 Newton. That means to make 60 to balance with what? 20. Something must be done to this 60. Something must be done to 20 rather. Meaning that the distance between 20 and the pivot, exactly, and this pivot and 60, that means the distance between this side and this side must be what? Higher than what? This and this. That's why movement is always what? First times what? Distance. Thank you. Now, look at this diagram now. Are you with me? A weight is being hung on the left hand side, which is what? 20 Newton. Another weight is hung on the what? Right hand side, which is what? 60 Newton. Obviously, by the weight, exactly. If you place it on the knife edge, it can't give us equilibrium like this. Exactly. That means this meter rope will tilt towards what side? It will tilt towards the left, which is what? 60 Newton. You know why it tilts? Because we have more weight on what? 60 Newton. Are you with me, my dear? Now, to now balance 60, because obviously 60 is more than what? 20. Now, for me to balance this meter rope so that it will not tilt towards 60, to make it balance like this meter rope now, that means I will have to reduce, I will have to reduce the what? The weight of what? I mean the distance of 60 Newton and increase the what? The distance of what? 20 Newton. Do you understand now? Okay?
Can't you just add 40 Newton?
Good. I love that. That's why you're a science student, physicist. He's saying that, okay, since we want to make it equilibrium, to be balanced, yes, what? 60. Yes, what? 20. Can't we add 40 Newton to what? 20 to make it what? 60. So when we have 60 here, 60 here to be balanced. Correct. But let's assume that the designer only gave you 60 Newton and what? 20 Newton. And he asked you to balance this on a knife edge. How will you do it? That means the best way to balance this with unequal what? Weight is to what? Increase this distance and what? Decrease this what? Distance. Do you understand? Now as you solve, you will understand better. Now if you check this diagram, you see the arrow is pointing like this. Exactly. And you know it's what? Clockwise. Now we want to solve this now. How do we solve this? Now from the diagram, we have this. This is the knife edge. Are you with me? And this is the weight here. 20 Newton. And we have this to what?
16 Newton.
16 Newton. And this weight is pointing downward. Exactly. Downward. Then from here, we have what? A. Yes, what? Yes, what? B.
B.
Very good. Now, we are asked to calculate the what? Find the what? Moment of the force about point what? This point O. Exactly. Are you with me? My dear, very good. Now, to now solve this now, we said the moment of force about point what? Point O is, now recall that moment is equal to what? Force times what? God bless you. Yeah, what are our force here?
20.
And give us M is equal to what? 20. What's the distance?
O.
A. No. Check it.
A.
This is distance. O is the center. A is the distance. Yeah, this is what? The distance. O is the center. Do you understand? Okay. Now you are trying, my dear. Very good. Very good. It's not a crime to make an effort. Exactly. Now, we have 20 times what? Times A. Exactly. Equals to what? On the other side, now for this side to be equal to this side, that give us what? 60 times what? V. Very good. Now therefore, moment is equal to 20 times A will give us what?
20.
God bless you. 20A. And 60 times B will give us what?
60.
60B. Now, because we are not given the distance, we just need to answer this way. 20A is equal to what? 60B. Do you understand?
Yes.
Okay. Very good. Now, in this case now, we are giving a value. Now look at this diagram again. A typical example of this. Exactly. Do you know that as you are seated, as you are seated on the chair, the reason why you are not falling from that chair is because the weight of your bum bum respect to that chair is what? Is equal. Yes. But if it's not equal, what happens? You fall. Can you know see if I ask you to sit down on this basket, what happens to that basket? It will compress. Because your weight is what is heavier than the what? The basket. The same thing here, check. Now look at this now. Example 6. A meter rule is what? Pivoted at its what? Midpoint what? C. With a vertical force of what? 10 Newton hanging from the what? Distance 30 meter from what? C. Very good. At what distance must a what? 15 Newton force hang to what?
Balance the ruler.
Now, check this now. Now it's not falling off, it's balanced. We are not told that here is what? 10 Newton. Here is what?
15.
Obviously, can it be balanced? No. Because the weight at 15 is what? More than what?
10.
That means this ruler will tilt towards what?
The right side.
Very good. Now, what can we now do to this 15 Newton and 10 Newton by making it balanced without increasing this 10 to what? To 15. Now, take note. Between 10 Newton and the pivot, what do we have?
27.
Between the pivot and the 15 Newton, what do we have?
Y.
That means, now, please take note. What do you have here? 10. What do you have here? 30. What do you have here? 15. That means if you solve, at the end of the solving, this distance will be what? Will be shorter than this. Now let's solve, you see. You get to understand better now. Now to solve this now, we want to check what can we do to move to make it what? Balance. Yes or no? Yes. Okay. Example 6. We are progressing now. The first thing I want this word is to find the word moment, isn't it? Now, take note. The other time I told us that this force move like this. This one comes what? Like this. Now check. See that this one is coming like this. I touch it again now. It is moving towards this side. I touch it again. Moving towards this side. I touch it. See it's going. It's going. Are you with me? Now, that means when it's coming towards this direction, what do you call it?
Anti-clockwise.
No, look at this. Clockwise. Like this. Anti-clockwise. This is clockwise. This is what? Now, to make this and this equal, that means the clockwise moment will be equal to what? Anti-clockwise what? Moment. Are you with me? Now, let's solve this. Don't forget, we want to balance this meter rule up horizontally. Now, you now say clockwise moment is equal to what? Anti what? Very good. Anti-clockwise moment. Is that clear? Now, here now is coming this way. What do we call it? Anti-clockwise. Very good. Now, what is the formula for moment? Force times
distance.
God bless you. That means you will now say force times distance, that is clockwise, is equal to what? Force what times
distance.
what?
Anti-clockwise.
God bless you. Now, what is the force for the clockwise? God bless you. Tell me it. The distance? 30 what?
30.
Now, the force for the anti-clockwise?
15
15 what?
Newton.
And the distance is what?
Y.
Y what? Centimeter. Now the reason why I'm not converting centimeter to meter is because it's a meter rule. And on the meter rule, it is always the word centimeter. Do you understand? Okay. 10 times 30.
300.
Is it equal to 15 times y?
15y.
15y. Exactly. Now let's get our what? Our y. Divide both sides by what?
15.
By 15. 15 cancel 15. Exactly. 15 here 1. 15 30.
20.
That's 20. Thank you. 20. And it's therefore y is equal to what? 20 what? Centimeter. That means for us to balance this to this now, exactly, here must be what? 20. It means that according to moment, the higher the force, the lower the what? The distance. When here was 10, we add what? 30. When it's now 50, we add what? 20. That is it. It means if the force, that means if you are being practical now, if the force is more here, what will happen to the distance? You have to reduce the distance to make it balanced. But if the force is less here, all you have to do the distance, you have to increase it. When you do that, what happens in the meter rule? The balance for equilibrium. Do you understand? Yes. Any question? Any question? Okay, now very good. Positive and negative what? Moments. Now check this diagram very well. I want to explain this diagram. Please pay attention. For this diagram, we lead to what we call the principle of moment. What do I call it? Principle of moment. Exactly. Now, positive and negative moment. If you check this moment now, we have 5 forces. Now let me show you now. The first force is F1. Thank you. F2. F3. F4. F5. Now take note. You will observe that F1, F2, F3, F4 are pointing what? Downward. Very good. You are very observant. And you know that F5 is pointing what? Upward. Very good. Now, how do we put this moment in equilibrium? Just like this. Equilibrium means it must be stable. Equal force on both sides. Very good. Now, F1 cover a distance what? God bless you. And meanwhile, if you check the distance is always reference to the pivot. Check. See, F1 to the pivot, give us what? A1. Look at F2. See, to the pivot, give us what? A2. Now look at F3. See, to the pivot, give us what?
A3.
Look at F4 to the pivot. A4. Now look at 5 to the pivot. A5. Now, let's now solve this now. Exactly. Let's see how do we get what we call positive and negative what? Moments. Some questions regarding moment if the force is more than what? More than one. If you have several forces. Like here now you have how many forces? 5 forces. Now, take note. If you look at this force now, are you with me? If I want to go clockwise, look at this. This is what?
Clockwise.
Now, if I tilt it like this guy will come in, this guy will go the other side. Exactly. Now, if I have something like this, are you with me? Now, I do like this. That's what?
Anti-clockwise.
Anti-clockwise. Very good. Now, take this. Look at this now. Look at F1 here. Are you with me? Look at F2. If I rotate, if this meter now comes like this, F1 will come like this. Are you with me? F2 like this. What will follow? No, F3 will come like this. I mean, what will go in the same direction with F1 and F2? F5, God bless you. F5. That means F1, F2, and F5 will be in the same what? Direction. Which is what? Anti-clockwise. Now look at this now. Anti-clockwise movement, we want to prove a formula. Anti-clockwise movement. Exactly. Now, that will give us Moment is equal to what? First times what?
Distance.
Distance. And here our distance is what? A. Thank you. Now let's first of all calculate what? Anti-clockwise moment. Now we have moment is equal to F1. Isn't it? Times what? A1 in brackets plus very good. F2 times what? Very good. Plus God bless you. F5 times what? A5. Let's stop there. Now clockwise what now? Clockwise moment. Moment is equal to now that means you have picked 1, 2 for anti-clockwise. We only have what now? 3 and what? 4. Now 3 gives us F3 times what? A3. Very good. Plus what?
F4
times what? A4. Now we want to see how this moment will result to positive and negative. Exactly. Now don't forget that under moment again, anti-clockwise moment must be equal to what?
The clockwise moment.
Very good. Very good. Now anti-clockwise moment is equal to what?
The clockwise
Clockwise moment. Is that clear?
Yes.
Now, what about anti-clockwise moment? F1, A1 plus what? F2 there
H2
plus what?
F5
F5 A5 equals to clockwise.
F3
I love that.
A3
Plus what?
F4 A4.
Very good. Now let's collect the what?
Like
terms.
terms.
So we now arrange them. Okay, let's first collect like terms first. We have F1 A1 plus what? F2 A2 plus what? Sorry, F5 A what? A5. Okay, once F3 come here, how will it become?
Minus.
God bless you. And as what? F3 A what? Minus what? F4 A4 is equals what? 0. Exactly, equals what? Now take note of this equation 1. Now for equation 2 now I'm not through yet. Now let us now arrange them sequentially. We have what? F1 A1 plus what? F2 plus what? No, minus what? No, minus
F4 A4 plus F5 A5.
Very good.
Equals to 0.
Very good. God bless you. Equation what?
2.
Very good. Now, according to what states that for equation 1, is that clear? That the word anti-clockwise moment is equal to what? Clockwise moment. Or it can be stated as equation 2 now that the algebraic sum of moment about a point equals what?
0.
0. Very good. Equals to 0. Now you see it now on the next slide. Now look at what I just put for you now. Is that clear? Now you see the principle now. Now let me show you. Yes. Now look at this place now. The what? Algebraic sum Equation 1. Or
Total clockwise moments of the forces at any point of the body must be equal to the total anti-clockwise moments of the forces about the same.
equation what? 1. Do you understand now? Now quickly conclude simply. Now from that diagram we have this expression which I proved to you. From this expression we now have condition of equilibrium under this that is the last part. Now that last part we summarize. Now conclusion of equilibrium under the word action of what? Parallel coplanar forces. Now coplanar forces are forces that lie in the same plane. Parallel forces are forces whose lines of action are all parallel to what? Each other. Hence, the two conditions for equilibrium of parallel coplanar forces can be what? Stated as follows. Which is what? Force and what? Moment. But we stop here, we stop at force, we stop at moment rather. Then, now what is forces? The objective sum of force acting on the body in any given direction must be what? 0. Now back to moment. The objective sum of the moment of all forces about any point on the body must be what? 0. Or the total what?
Clockwise moment
of the forces about any point of the body must what? Equal to what? And the clockwise total and the clockwise moment of the force about the what? Same point. Now, finally, it means that you have talked about generally on moment. Exactly. Now, what you need to understand basically under moment is moment must have to do with what? Force and distance. And at equilibrium, at a stable condition, it means the clockwise movement must what? Always be equal to the anti-clockwise movement. Thank you so much.
Thanks so much for joining us for this week. Have a pleasant week ahead. See you next time.
Oh yes, your long-awaited Citadel of True Education for the Rare Gems, Monarch Model College Challenge Ibadan. Intelligence with good character makes up the real goal of true education. Parent and guidance, connect your child to the arena of kings and queens, where quality and sound education is undoubtedly available. It's a government-approved school that stands tall, among others, with the best and globally acceptable standard of teaching, beautiful and hygienic learning environment, professional subject teachers, well-ventilated classrooms with small class size, ultra-modern science laboratory, standard music lab, standard computer laboratory, maximum security with CCTV surveillance. School buses are also available, all with affordable school fees. Admission is ongoing into GSS 123 and XS 122 classes. Application forms are available at Monarch Model College, plot 8687 Polariwa Street, behind Egoa Church, Police Post, Challenge Ibadan. 0069799661. Website www.monarchmodelcollege.org. Monarch Model College, a community of kings and queens.
Share, listen to Aloore Radio on Facebook. Aloore Radio, the voice of Oyo State.